the torsional vibration for single degree of freedom undam. Our member is CORINA, FARAHHIN, Amirul, Nazrin, and me, MUHAMAD.
From group 6, and we will be presenting about undam single degree of freedom for torsional vibration. So now for this week we have decided to do about 3 objectives. Our first objective is to determine the decay rate of the system using different rod diameters, and then the second objective would be to determine the natural frequency of the system for different rod diameters and compare it with the theoretical value. And the third one is to determine the relationship between the stiffness value, the natural frequency, and the decay rate. So now we'll start with the experiment for natural frequency. So now this will be our ring, and our natural, and with the only thing that will change is the rod diameter, and then the sensor and the load and all that we will fix it to 200 grams. So now what we'll do is that since we have connected the system to the sensor, to the LVDT, to the computer, we'll have our. So this is our plan layout for our daisy lab. So now that our first thing is that we want our natural frequency. So what we'll do is this would be our layout for our natural frequency. We've already connected it to the data window, which is under, and we'll change it to rectangle with a block size of 2048. And then we'll connect it to our YT chart so we can have a display. So now what we do is we'll give a force to the system and we'll play. So now as you can see, this would be our, we'll freeze this, we'll stop the system, and then this would be our damping frequency for this system.
For second objective, we will determine the decay rate of the system. The experimental procedure is the same with the natural frequency objective. We just manipulate the mass and the diameter of rod, and then we fix the mass. The mass is fixed about 200 grams, and after we do the experimental procedure, we connect it to the daisy lab. So this is the worksheet of the daisy lab. To determine the decay rate, first we give force to the system, and then we click play. Then this is the decay rate, the graph of the decay rate. We click stop button, and then this is the graph. So to find the decay rate, first of all we need to click survey, and then we just move the cursor to each peak of maximum point, and then calculate to determine the decay rate. Then we're going to change the diameter of the rod in determining the difference of the decay rate and the natural frequency. So this is how we change the diameter of rod.
I see your frown and it's like looking down the barrel of a gun, and it goes off. How come all these words? Oh, there's a very pleasant side to you, a side I much prefer is one that's laughs and jokes about.
After the experiment, we can conclude that the decay rate is depends on the road diameter, and the road stiffness and natural frequency is directly proportional to the road diameter. But the decay rate is inversely proportional to the road diameter. It means the higher the diameter road and the lower it gives to the decay rate.